presentation. Uh, the takeaway of this presentation would be really beneficial for two types of audiences. One is the potential clients or the people who wish to go for solar, who wish to install solar power plants either on their residences or industries or schools, colleges, hospitals, anywhere. So the concepts would be really helpful for them. And the second kind of audience who would really get benefited out of this presentation is the student community if they wish to make their careers in solar domain. So let us start without wasting much of time. Let us start with the basics. In solar, basically there are two types of solar technologies. One is thermal and the other one is photovoltaic. What is the difference? There is a huge difference. Thermal technology deals with the exchange of heat to heat. Heat energy is converted to heat energy. For example, solar water heater. So what it does, it captures the solar heat and then heats up the water. Thereby, heat is converted to heat. Here you don't get any electricity production. So this is called as thermal technology. To make it simple, I don't want to deviate and make different types of thermal technologies are there. What we see on the rooftop is ETC and FPC. What is ETC? ETC stands for evacuated tube collectors. You see the tubes, dark colored tubes, glass tubes, which the tubes are covered with some special coating which enhances the heating of the water. So due to gravity, the water flows into the tube, gets heated by the sun heat, and then it travels towards the tank. So thereby, normally it takes about 4 to 5 hours to reach 80 degrees to 100 degrees of temperature. In the same technology and the same working principle, you have flat plate collector, wherein there is a copper sheet welded to the copper tubes and the water flows through the copper tubes and the copper plate is painted with black material which increases the heat absorption. So thereby the water is heated and the hot water, since it becomes lighter, so it travels towards the tank, and thereby the siphon effect, the circulation goes on. In next 4 or 5 hours it gets heated up to 80 degrees to 100 degrees. This is called FPC, flat plate collector. And be careful, suppose you have a pressure pump in your house, you should indicate to the supplier or the vendor that you are using a pressure pump in the house. Otherwise, you have two types of solar water heaters. One is for non-pressurized, the other one is pressurized. So if you use a non-pressurized or a ETC model for the pressurized system, the tubes will definitely break. So this is thermal technology. Now coming to the photovoltaic technology, here the sunlight is converted to electricity. You must have seen we normally use the calculators. So there is a small cell, solar cell, which captures the energy, light energy, and it charges the battery and then it works. So the working principle is capturing the sunlight, not heat, and convert it into electricity. This predominantly, there are three types of solar power plants. One is off-grid, the other one is on-grid, and the third one is hybrid. Now, quickly, I'll just browse through the working principles and the major differences between these three.
No voice.
Sir, you're not audible, sir. You're not audible.
I have connected Nazeem bhai, he'll join back.
We're talking of, right? Sorry for the inconvenience. Am I audible?
Yes, sir, you are audible.
Okay, thank you. So for the first type of the solar power plant is called as off-grid. Here, the grid means the electricity line which comes from the government departments or the public utility departments. Like in Bangalore, we call BESCOM, Bangalore Electricity Supply Company. So this is the meaning of grid. Why it is called off-grid? Because whatever solar energy you are generating, you're not pumping back to the grid. You're just consuming or you're saving in the battery bank. It is simple in terms, in simple words terminology, it is like a home UPS. You have a UPS, you have a battery, and you have solar modules. So the solar modules captures the solar energy and charges the batteries. And the UPS will help you to utilize the power from the battery. As simple as that. Now the second type of plant is called as on-grid plant. Here you don't have the batteries. So the on-grid inverter senses the waveform of the power supply, that is grid, and generates the energy. The solar energy is synchronized with the grid. Note my words. The solar energy is synchronized with the grid, and either it is consumed or it is exported back to the grid. So this we called as export of energy. Whatever energy you take from the BESCOM or from the EB or from the grid, that is called import. and what is excess amount of energy which is sent back to the grid, pumped back to the grid, that is called as export. So at the end of the month, what you get a bill is called as a net meter bill. Here the meter will be replaced with a bidirectional meter, energy meter, which documents the consumption, the energy generated, and the energy imported, and the energy exported. So finally you get a net meter, export minus import, and whatever the units you have consumed, only those units you have to pay to the department. For example, say let me give a classic example of 5 kilowatts. You want to go for a 5 kilowatts of solar power plant for your house. So this 5 kilo solar power plant, as a thumb rule, it needs about 100 square feet per kilowatt. So for 5 kilowatt, you approximately need at least, say, about 500 square feet of shadow-free rooftop area to keep the solar modules. This 1 kilowatt will generate about 4 units of electrical energy per day with respect to Bangalore weather. With respect to Bangalore weather, in general, Indian weather. Of course, there are many installations where the generation has crossed 6 units per day also. But that is not a standard, not a generic figure. As a thumb rule, you can take as 4 units of electricity will be generated per day per kilowatt. So 5 kilowatts will give you about 20 units per day. So into 30, about 600 of electric unit you can generate by installing a 5 kilowatt on-grid solar power plant. Suppose if you are paying, say, 10 rupees per unit, so 10 rupees into 600, that is 6,000 rupees is the saving on your electricity bill. So this is called as an on-grid system. And point to be noted, when the grid fails, when the BESCOM fails, this on-grid inverter also will shut down. It has no backup, no storage. This point is to be noted, because the on-grid system, the on-grid inverter has to get a reference voltage, some reference voltage, and that is the reference voltage is the grid voltage. When the grid is zero, solar also will become zero. It will not generate any energy. So this is the difference between off-grid and on-grid. Now coming to the hybrid. What is hybrid? It is a mixture of off-grid and on-grid. So in other words, hybrid system has a net meter, it has a solar module, it has a hybrid inverter, and also it has a battery bank. When you talk of batteries, you have the legendary conventional lead acid batteries, tubular batteries. But now, due to the advent of technology, lithium batteries are very, very common, even though they are 40 to 50% more expensive than the tubular battery. People are preferring to go for lithium batteries for the simple reason is that they don't need any maintenance. And also the life, your expected life, if the quality is good, then you can expect more than 10 years of life. Now coming to the EPC phases. What does EPC stand for? EPC stands for engineering, procurement, and construction. Engineering design is the first and the most important step in any EPC phase. There is a saying that your saving starts in the first step of design. If the design is poor, then definitely the plant will not yield the optimum level of energy, or it will end up with so many problems. Subsequently, we can see, I'll give you some practical examples, like what type of problems you might face because of poor design. Example, there was one call from one of my friends. He is a O&M manager for a very large company called Energy, NG company of France. And he was the site project manager for a project of several 2 megawatt projects, solar power plants. Then he called me. Then he told me, Nazeem Sabre, 2 megawatts plant ಇದೆ, ತುಂಬಾ ಕಡಿಮೆ ಬರ್ತಾ ಇದೆ. ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ಬಂದ್ಬಿಟ್ಟು 15 ಲಕ್ಷ ಯೂನಿಟ್ ಪರ್ ಒಂದು ವರ್ಷಕ್ಕೆ ಬರಬೇಕು. It is not coming. I am hardly getting around 10 lakh units per annum. Just come and have a look. His problem was that though they are using premium quality solar modules and premium quality solar inverters, the inverter was from Germany called SMA. It is one of the best in the world. So I went there with my electrical team just for analysis what could be the problem. Then I identified two problems. One problem was that the inclination of the solar modules was not perfectly or rightly designed. For Bangalore and for Karnataka region, the inclination should be north-south around 13.5 degrees. North-south, point to be noted. Because if it is east-west, then the shadow will fall in the second half, and in the second half, the shadow will fall on the eastern side. So there will be a drop in production, drop in yield of energy. So the best inclination is north-south 13.5 degrees. Then I put the clamp meter to the DC cable and I asked my boys to increase the angle. We could easily note that from 6.5 amperes, the current increased to 7.5 amperes. Then we showed that difference of better performance to the client. See, this is one of the reasons why you are getting very low yield. Now, the second reason was the
Sir, you're not audible, sir.
Yeah, sorry for the interruption. There was some Wi-Fi connection was not there. So okay, I hope I'm audible now.
Yes, sir. Yes, sir, you're audible.
Yeah. So I was mentioning about the increase in the DC current. From 6.5, it came to 7.5. Then it is almost about 12% to 15% increase in the yield. So the second problem was that the 6 inverters were burnt, and in 6 months. So my task was to find the reason. What was the reason why there is
Nazeem
a
bhai, please share your PPT once more. It is not visible.
okay. So my
We can see.
task was to find out the reason why every month one inverter is getting burnt. You will be really surprised. The reason was lizard. Chipkali. You know how? Why? Because before the connecting the inverter, there is a DC-DB box where the DC cables come and get terminated, and there are holes in the box where the cable enters, and you are supposed to put a cable gland. The cost of the cable gland may not be more than 2 rupees, but the EPC person who has done the work, the installation technician, either he has forgotten to put the cable gland, or it was not designed, or it was just carelessness, not bothered to follow the best practices. So they have not put the cable gland. So what happens? The lizard will creep inside, it will go, and then there is a positive negative short. So this will damage the motherboard of the inverter. So every 1 month there is one inverter failure. So I showed them this is the root cause why the systems are getting burnt again and again. So I just wanted to highlight you why engineering design is very, very crucial and very, very important. Otherwise, the megawatt projects, when the plant is down, say for example, it is a 1 megawatt plant. So if the plant is down for say even 1 month, you are losing almost 1.2 or 1.3 million units of electrical energy, solar energy, and it is directly loss of revenue for the plant owner. So that is the reason why engineering design is very, very important. And even though you are using premium products, reputed modules and inverters, if the balance of the system, we call the balance of system, there are 3 major components in any solar power plant. One is the solar modules, the other one is the solar inverter, and the third part, collectively we call that as BOS, balance of system. So there, if the design is poor and the quality of the balance of system is poor, then the plant is bound to fail. The second part is procurement. See, this is not a very big criteria for small plants or small these things. But when you talk of 100 megawatts, 200 megawatts, if there is a delay of say even 1 month, 2 months, 3 months, then the generation is affected. So it directly affects your ROI, return on investment. So the purchase department should be technically sound and competitive and professional to choose the right vendor and the right product at the right price. Sometimes there is a hidden loss in the procurement process. If there are, say, 3 quotations, L1, L2, L3, and you need not always go with L1. Sometimes it makes prudent decision to go with L2 because his supply chain management is very strong. He is prompt in supply, he is prompt in service. All these criteria, you have to go for L2, not the L1. Because even if the quality is good, but if he is not giving on time, then you are losing so many units of energy per day. Now coming to the third part, construction. This is the actual part and the most important step in the EPC phase. Because, see, for example, solar modules. The management can easily decide thus, yes, we are going for a tier 1 reputed brands. Say it may be Adani, Tata, Vikram Solar, MB Solar, Axitec. We always promote Axitec, that is from Germany actually. It comes with a 30 years product warranty. So when you compare the efficiency and the price, there is hardly 1 or 2% difference with respect to the efficiency. Say Adani may be giving 23.4% efficiency on the solar module, and Tata may be giving say 23.2, Axitec may be giving 23.6, like that. 0.2% or 0.1%, there is a difference in efficiency. But the construction, the workmanship, there is a huge difference. As I gave you some classic examples of this 2 megawatts plant in Chintamani, Kolar district. So if the workmanship is poor, then the plant is going to suffer. So let us move forward. I hope I am clear with these 3 basic steps of EPC.
Yes, sir.
Now coming to the life cycle. See, suppose if you are talking of a megawatt plant, the first and foremost is planning. You have to hire experienced, knowledgeable consultants for planning. Never ever do the mistake of doing the planning yourself, because it's a lot of engineering is involved in planning. Solar domain needs 5 types of engineering. One is civil engineering, the second one is mechanical engineering, and the third one is electrical engineering, and the fourth is electronics, and the fifth is computers. Why you need civil engineering knowledge? Because you need to do the groundwork, that is called as piling, and lot of cement concrete work goes into that. Then you have mechanical engineering. You have to design the MMS, module mounting structure, and it is galvanized. Why? Because the plant warranty is more than 30 years. The life is 50 years. So the structure has to sustain for 50 years. It has to sustain the corrosion. It has to sustain the wind speeds, cyclonic effects, and all these things. So you need mechanical engineering also. Then you need electrical engineering, because this current electricity which is produced by solar is ultimately boosted. It may be 11,000 volts, 11 kVA, 3 kVA, or 66, or more than that. So it is the electrical energy is boosted for transmission. Then it goes to the substation. From there it goes to the main grid, state grid, and then it goes to the national grid. So planning is very, very important. And finally, you need knowledge of electronics and computers, because this computer engineering is very, very important for data acquisition and management, monitoring, that we called as a SCADA. When you visit a megawatt plant, there you will see air conditions, large rooms full of electronics and computers, which will be monitoring the plant, which string is faulty, which is giving more energy, which is giving less energy. All this data will be on your fingertips. So you can get the Excel sheets and the MIS reports and daily reports, monthly reports, annual reports for the generation of the energy. Now, after planning, you do the execution. That is where the exact EPC team comes into place. Already I've explained to you how to choose L1, L2, L3, and how to choose the correct installation team and all those things. So this execution, the beauty of solar power plant is that when you compare with other plants like hydroelectric or wind or anything, solar power plants execution is very, very fast. Suppose if you take a hydroelectric project, it may take more than 10 years to construct a dam, then storage, reservoir, and do the civil work. But here, the same 100 megawatts or a 200 megawatts, it can be executed in just 1 year. Now, coming to the operation and maintenance, this is also very important. Once the project is completed and handed over, you need to engage the operation and maintenance team, because without proper operation and maintenance, the energy output will be depleting and it will go down. It is seen that when the modules are clean and well maintained, you get the maximum output. And if they are not maintained, the dust accumulation, the output yield can go even more than 20 to 30% lower than the rated output. So operation and maintenance is very, very important. Let us move forward. So this is the that was the basic of EPC life cycle and other things. Suppose you want to start a solar company. You want to start a solar EPC business. So you should define what is the purpose. You should have passion for solar, and then you should have profits. You have purpose, you have passion, but you don't have profits, then it is not a sustainable business. Then you'll lose your money, you'll burn, that's called cash burning, then you'll burn your cash and then you'll wind up. So all these three are important. You should have a purpose, why you are starting this business. You should have interest, you should have passion for this, and you should have profits. Knowledge and honesty is very, very important. For any business, knowledge and honesty is very important. I do skill development, I do training, teaching for engineering students. So I give a classical example. Suppose I have a scooter. And I want to get it repaired. So I go to a mechanic who is very knowledgeable, who is talented, experienced, but he is not an honest person. There are chances that he may replace the original parts with the duplicate ones. He may cheat me. Then as a owner, what I do as a customer, I try to avoid him. I don't prefer to go to that mechanic. Another mechanic is there. He is very, very honest, very religious, and his characters, everything is good, but he has no knowledge of the technology and the scooter. I am worried if I give my scooter, brand new scooter for repair, he is likely to spoil the engine. So in that case also I try to avoid him. I say, आदमी तो बहुत अच्छा है, लेकिन अनाड़ी है, वो काम नहीं जानता. So these two principles, which I have copied from, I have learned from the holy book Quran. So there are so many holy books, and in every holy book, whether it is Quran, Bible, or Ramayana, Bhagavad Gita, Mahabharata, whatever it is there are some points of wisdom. So you have to take those points of wisdom. So knowledge and honesty is very, very important. Now, when you talk of knowledge, see, there is a technical knowledge. You should have the proper technical knowledge of the solar domain. If you are not having technical knowledge, then you should hire the people, experts from the industry. So without technical knowledge, you should not start the solar business. Now, the second is commercial knowledge. Commercial knowledge is also very, very important. If you don't have commercial knowledge, then there are chances that your business will not be a sustainable business model because it is not generating profits for you. For starting any business, one of the aim and objective is to make profits, reasonable profits. I'll give an example. I visited my friend's place in Madikere, Coorg. I saw a new factory which manufactures nails, and within 6 months it is closed. Then my friend explained to me the reason for closing was that person was from he was Saudi returned. He came back to India. He had a lot of money savings, and some of his friends suggested, why don't you start a factory in the industrial area and start manufacturing nails. Then he calculated the cost, landing cost, material cost, labor cost, everything he calculated. It was about 10 paisa. Example I'm giving you, 10 paisa per nail. Each nail was 10 paisa. And the selling price was 12 paisa. So the profit was 2 paisa per nail. That is a decent 20% margin. But he did a mistake of not calculating the transportation charges. So he started production and he started making millions of nails, and then he transported to Chickpet, Bangalore city market. The transportation cost was almost 2 paisa. And the payment was not coming instantly in advance from the B2B clients. So then what happened? 6 months, month on month, it was a loss for him. And within 6 months, he closed down the business. So why I'm giving this example is that you should have both technical knowledge and the commercial knowledge. And then you should have the moral standards. Whatever company you are forming, you should have a company policy. I was really inspired by Narayan Murthy of Infosys. He has mentioned this in several interviews also. When he started Infosys, and those days, computers were imported from America. So I think 2 computers came from America and they were in the customs department. And the customs department, that person was asking some bribe. And as a policy of Infosys, they had made a policy that we should not give bribe to anyone. So whenever he goes to the customs office, that person will indirectly ask for bribe, and Narayan Murthy will go and wait there hours together, but he never paid a single rupee as a bribe. And it was amazing to listen to his speech. He went for 6 months non-stop. Every day he used to go there and wait there, sit there. And finally that officer was fed up, and then he released the computers. So every big company, what you see today, they are having some moral standards. So you also have to inculcate and set some company policy, some moral standards for the company. Now, vigilance is very, very important. When you start the business, it's very easy to start, but you have to see whether it's growing or not growing. See, growth is a symbol of life. When you put a seed, okay, so it will start germinating, and then the plant shoot and other thing, then it slowly grows. If it is not growing, then it is a concern. See, why it is not growing? So one fine day that plant may fade away. So growth is very, very important. And then you have to consolidate the business. Consolidate means you have to take care of your customers, you have to take care of your staff, because without a team, you cannot run a business. There is a saying, if you're doing all the things by yourself, you're doing sales, you're doing service, you're doing accounts for everything yourself, and you're not having a team to do those tasks, then it is not a business, it is a trap. It is a trap of self-employment. So be careful. You should have consolidation on the customers, on the team and the staff and everything, and then you should be vigilant. Next. So how you manage your business? How you exit? Either you have a family succession, either you have your family members like second generation, either son, daughter taking up the responsibilities, and you have a smooth transition of passing over the mantle to your children and then come out of the business. Or you should liquidate the shares and take your company to the IPO and make it a public limited company, and you should hire one of the best teams, advisory board, and then you give the task of running the company to the advisory board and the board of directors. If nothing is happening, then it is really, really wise, it's prudent to wind up the company at the right time, because the more you delay, the more losses will pile up. So you need to consult your chartered accountant, your family members, your well-wishers, if it is really wise enough to wind up the startup company or whatever company you are having at the right time. It is not a surprise. In India, 97% of the startup companies, they are closed in less than 1 or 2 years. This is a very, very common problem. So you should be very, very careful before starting any business. Next. So that was the insights and the other useful tips for the EPC business. Now, these are the useful tips for potential clients. Suppose you are a potential client, you want to install a solar power plant for your house, for your industry, for your school, college, or a hospital, or anything. Or you have a lot of money and you want to start an open access megawatt project and sell the energy to the BESCOM or the private consumers. That is called as IPP, Independent Power Producers. You want to become an IPP. You want to install a solar power plant and you want to sell to the consumers, either government or private consumers. So the first and foremost thing is that you have to define your need, why you are going for solar. For example, one of my customer from OT, I got an order for say 10 kilowatts, and it is running from the past 2 years very successfully. The reason for him to go for solar was that he has a farmhouse on the top of the hill. There is no grid connection, there are no roads, nothing. And the only source is either wind or solar. So he was very clear, he wants solar because there is no power. So we designed a standalone solar off-grid system which will charge the batteries, and then there is a sufficiently sized inverter which supplies power to the refrigerator, to the television or the computers and the water pumps and the geysers, heaters, all these things. So you should define why you want to go for solar. The second reason might be to reduce the electricity bills. In Karnataka, it's fortunate and it's still attractive that unit to unit deduction of electricity bill is possible. Suppose say you are using 1,000 units of electricity units in a month. Now you put a 5 kilowatt power plant. So it will generate almost around 600 units per month. So out of 1,000, 600 units will be deducted from your electricity bill. You are supposed to pay only the cost of 400 units. So this could be the second reason. The third reason is climate change, environmental reasons. See, I have money, I don't need a solar power plant, but there is a huge environmental problem, global problem, that is carbon footprint. So I want to contribute to the solution. So that could be one of the reasons why you are investing on the solar. The fourth reason could be tax benefits. Suppose I am paying a lot of income tax, and there are so many government policies and benefits, tax benefits, that is called as accelerated depreciation. Suppose I am paying say X amount of rupees as an income tax, and I go for solar. In order to encourage renewable energy, the government of various states, in general Indian government, they have given very, very attractive schemes. In the first year and the second year, you can deduct 40%, and in the third year, you can deduct 20%. It means that in the 3 years of time, your solar plant is free of cost for you. So this could be one of the reasons for tax benefits. So you have to define why you are going for the solar. That's the first step. Now, secondly, when you want to buy a solar, you shortlist some reputed companies which are known for quality work, quality products, quality service. Nowadays, due to digital marketing techniques and SEO techniques, so there could be a trap for you through Google marketing, through digital marketing. So you should be careful in selecting the vendors. So you take three quotations from 3 reputed vendors, and then try to understand if there is a vast difference in price. I remember around 20 years ago, my sales engineer came and told me, Nazeem bhai, I lost the order because my quotation was 80,000 and another vendor quoted for 30,000 rupees. Then he was a trainee engineer, newly joined my company. Then I told him, brother, say this is not possible. My quotation cannot be 200% more than my competition. There should be some reason for losing the order. So I took him and went back to the client, and I sat with the client to discuss the quotations. I told the client, and client had already decided Nazeem is cheating me and Nazeem is quoting more. I don't want to buy from him. Then I told him, sir, give me 5 minutes. I wish to explain to you. Then he was kind enough to discuss for 5 minutes. I told him, sir, I have quoted online double conversion through online UPS systems and with isolation transformer, and there is no changeover, and these are the features. If somebody is giving you for 30,000 rupees the same UPS and the same features, and that too with 6 batteries, you please go ahead and buy that. But ensure that what you are buying with knowledge. And if you're not buying from me, you should know the reason why you're not buying from me. Then he was really enlightened, like, yeah, aapki baat to sahi hai, let me check. He called up the vendor. He asked me, Is it online? Is it double conversion? Is it 6 batteries? All this he started asking. Then he said, no, sir, it is offline, sir. It comes with only 2 batteries, sir. How can I give you online UPS for 80,000, 30,000 rupees, sir? It is not possible, sir. Then he said, okay, keep on hold. I will get back to you. Then he placed the order to me, and then my sales engineer was so happy that it was a learning for him. It was a practical demonstration of sales and marketing. So why I'm telling you this is you have to always understand the reason for difference in prices. 3 things you have to note: quality, service, and price. All are equally important. For example, you can go to some EPC providers who are very well known for quality workmanship, like L&T. Larsen Toubro is one of the best EPC company in the world, not only in India, but in the world. Like that, you have Sterling and Wilson. There are some few companies you can talk to them and understand why their prices are more. Now, coming to the 4th point, focus on TCS. This is a project management summary. I have attended so many classes in wind technologies, in project management, and other things. In the project management, I summarize these 3 things, and also I teach them to my students: time, cost, and scope. Any project, these 3 are very, very important. How much time he needs to complete the project. Suppose after completing the project, if there is any downtime, then what will be the loss for my generation of energy? That is also very important. The cost. In the beginning, the cost may be very less. For example, MMS is a component in a solar plant. And if it is not galvanized, there is a standard that 80 microns galvanization is necessary to prevent corrosion. If the galvanization is not done, then within 5 to 10 years, the structure will collapse. The structure will collapse. And then the cost will definitely be double the cost of the previous one, because you have to replace the complete structure. And we have done this practically to several customers who had gone for a very cheap, low priced quotations, and they regret later on. That is called as penny wise, pound foolish. Now coming to the scope, I remember one project in Narsapura, near Kolar. There is one industrial area called Narsapura. There is one company called Wistron. You must have heard of Wistron. They manufacture iPhones. And the project was very interesting, and it was 400 kilowatts rooftop solar power plant. And I lost the order because of price. It was a narrow margin, just maybe around 10 lakh rupees or 12 lakh rupees. I was very much disappointed after losing that prestigious order. Then what happened? I was so confident that my price was very good and it was supposed to be one of the lowest price. But how could I lose that? I was wondering. Then what happened? After 1 year or 2 years, I saw the news in the market. In the media, I could see the news. The complete solar power plant was blown away due to wind. So what was the root cause? The aluminum structure which was given by the vendor was so thin and so flimsy, it was not durable and it did not withstand the cyclonic winds. So the complete plant was blown away. It was collapsed. Then so many other issues must have erupted, like legal issues, that is safety issues, and other things. So I wanted to give you a example where, especially in the large projects, you should not cut corners. You should not go with the cheapest option always. Poor EPC is very, very dangerous. For example, fire hazards due to hot spots and sparking. I'll give an example. I hope I am audible. Of course, in the last, after the last
Yes, sir, you're audible.
last slide, I will give an chance to ask questions. Question and answer session is there. But just to, out of curiosity, I'm asking. I hope I am audible.
Yes, you are.
Yes, sir, you're
Thank you.
audible.
Yes, Abrar Hussain, Mr. Mubin Sheikh, yes, audible now. Thank you. Thank you for your confirmation. Fire hazards due to hotspots and sparking. See, you must be having the world's best solar modules, the world's best solar inverter. But the story doesn't end here. You should have the best BOS, and the team which is doing the installation work, they should follow diligently the best practices, world class best practices. Otherwise, in the beginning, the plant looks very neat, very tidy, but as the production starts, as the DC current starts flowing, then there are a lot of hot spots created that may catch fire. I can show you some videos and some pictures where there are accidents happen due to hotspots. And the sparking, wherever there is loose connection, and the sparking happens, and that will trigger the fire hazards. See, this electrical, the normal uneducated electricians normally doing the work, they don't have any technical knowledge of calculation of the cable thickness. I'll give an example. My friend, Mr. Ramkrishna, he's my advisor and he's my off-grid UPS design engineer, and he manufactures off-grid UPS for me. He gave an example. In one petrol bunk, there was a service call. The backup time is not sufficient. So what the petrol bunk owner has done, he has replaced the batteries with the brand new ones, and that too exit batteries. But still, the backup should be at least say 2 to 4 hours. The backup is hardly coming for 1 hour. Then he has called so many UPS vendors, traders. Everybody have failed. They are not able to identify the reason. So when Ramakrishna went there for analyzing the problem, he noted that the DC cable from the UPS to the batteries, it should be less than 2 meters. But in this case, it was more than 10 meters. Then he explained to the customer, sir, batteries are good, UPS is good, but the problem is the design problem. The cable from the UPS to the batteries is 10 meters, and for every meter, there is a drop of 0.1 volts. So what happens? The 0.1 into 10 meters is equal to 1 volt. You know that the battery standard voltage is 12 volts. There is a high cutoff and low cutoff. When the battery is fully charged to 13.5 volts, the UPS will switch off the charging. And when it starts discharging, we normally fix it at 10.5 volts. When it comes to 10.5 volts, the UPS will stop working because it shows low battery indication. Now, because of the cable, we are losing 1 volt. So when it comes to 10.5 volts, actually it is 11.5 volts. Because of the cable, it is showing 10.5 volts. So this 2 volts, that is 13.5 volts to 10.5 volts, the 3 volts, the difference is for 4 hours. So now 11.5 it is giving cutoff, so the backup time is reduced. So by just keeping the batteries closer to the UPS, the problem was solved. So this example of why I'm giving you is that you should have knowledge when it comes to the technicality of the plant. Plant collapse due to winds, cyclones, and corrosions. Wind energy is very, very dangerous. I have attended a course in wind technology, and of course, that is very complicated design methodology and lot of formulas and lot of technical stuff goes into the design of the wind turbines. It is 200 pages booklet, what the study material, what was given to me. In that, I have noted one formula which is very, very, very important. Just to make it simple, I don't want to give you some scaring formulas which are 2 page, 3 page. I'll just give one sentence, one equation. E, energy E is proportional to V cube. E is the energy generated and V is the velocity of the wind. Suppose if the wind speed is say 10 meters per second, then the energy generated is 10 into 10 into 10. That is 1000 units of energy is generated. Example. Now, if the speed becomes 20, so the energy will not become 2000, but the energy will become 20 into 20 into 20. How much? 8,000. Am I right? Yeah, 8,000 units. Now see the energy built up. So that's the reason why when the wind, heavy winds, high speed winds flow, the wind turbines or the solar plants will start flying in the air because of the huge energy which is built up. So the design of the plant should be in such a way that it should withstand the cyclonic winds also. So normally in Kamati Solar Private Limited, we follow the stringent world-class standards, and we try to design for 140 kilometers per hour wind speed. Poor yield of energy due to downtime, as I've already explained to you, if the plant is down, then it's directly hitting your revenue. So many units of energy is lost due to downtime. So the uptime of the plant is very, very important criteria for a profitable ROI. Poor ROI due to poor design and poor workmanship, already explained. Low quality of the BOS and workmanship is the main culprits, already explained to you. Now this is part A is finished. Now we have just 5 to 10 minutes of career options discussions. This portion of the discussion would be really useful for the student community. I don't know how many students are participating here. Anyway, it's difficult to identify the students. Well, There are 5 career options in solar domain. The first and foremost is R&D, which is most complicated, and this is suitable only for those candidates who are serious, crazy about solar engineering, who have patience to do their graduation and then masters and PhD and get into the R&D of the solar domain. And there are so many problems to be resolved. So this is a very, very challenging field. Hundreds and thousands of engineers, they are working on the R&D domain to increase, for example, to increase the efficiency of the solar modules. You'll be surprised that even after 40, 50 years of R&D, the efficiency of the commercially available solar modules is not more than 25%. So you have a lot of gap where you can fill it up. Even if you can make from 25% to 30%, it would be really appreciated and it will be really rewarded in the industry. So the first and foremost option is R&D, and this I don't recommend for everyone. It is only for few brilliant engineers, students who can have patience and make their career in the research and development. The second is design engineer. This you need mechanical background, mechanical engineering background, and you should have knowledge of PV solar PV system. It's a software tool, and of course there are so many other tools also, and of course there are some AutoCAD related tools, design tools, which you have to master, and you can become a design engineer, and you will get wonderful opportunities to work with the large APC companies both in India and abroad. Then you have a project engineer. If you are a graduate or a diploma, you can become a project engineer, and then you can scale up and grow in your career by becoming a project manager and then project director. You can become a project director eventually after a couple of years of experience. Here you need to have the knowledge of engineering, procurement, and construction. Here the labor management comes into picture. So both the machines and the man, both you have to manage. So this needs a very, very challenging set of skills. Now comes fourth one is the solar technician. We need more than 1 million. I can share you some screenshots from a Mercom website. There is a demand of 1 million technicians in the renewable energy from India to the overseas countries for the foreign countries. 1 million means 10 lakh technicians are required for the global renewable energy sector. So this is of course, this is a green collar job, or we call it that as a blue collar job. The salaries are less, but the opportunities are more. And once you have 3 years of experience, then you can demand a better salary also. The fifth one is consultants. Suppose you have a large experience as a consultant in the MEP, mechanical, electrical, and plumbing domain, you can become a consultant in the solar domain. So this is also highly rewarding, high profile job. So I hope these slides and piece of information was useful to you. And thanks for giving an opportunity. It's a learning for me too also. I welcome some questions. Any questions? No questions means you have not understood anything or you have understood everything.
Assalamu alaikum. Ji,
Walaikum
Nazeem bhai.
salam.
Nazeem bhai,
Yes.
Abrar Hussain from Australia.
Yes.
Thanks for your time. एक सवाल था नजीम भाई, आपके पास एक लेआउट है क्या, एक सिंपल लेआउट ऑफ अ सोलर पावर प्लांट?
Yeah, I can share.
If you can, please. Just to get a basic understanding of what's involved.
Yeah.
Yeah.
If I share you SLTs, that is okay?
Yeah. That's fine. Or maybe on the group. I don't know if you want to share it on the group.
Done.
Okay.
Some SLTs of large power plants will be very scary, but anyway, I'll share with you.
A simple one. You got my number.
Yeah,
You can say
okay.
share it personally.
Okay.
Or yeah, I'll send you a text message and a WhatsApp message. You can share it on that.
Yeah. You can take on my WhatsApp number 99800.
Yeah, I've got it in the group. I'll text you.
It's there, no? Yeah.
Yeah.
Okay. Same.
Yeah. Thanks.
Shuaib bhai, Saib bhai, shall we close?
Assalamu alaikum.
Walaikum salam.
Nazeem bhai, this is Irshad Ahmad from Bijapur, Karnataka.
Okay, welcome.
I just want to ask you, if we want to have 1 acre of land power plant, so what is the procedure and also for that? I am in
1
solar
acre.
business. 1 acre land. So can we do it for? I have 3 inquiries for that actually for 1 acre and land. So I do small projects like 3 kilowatt, 5 kilowatt, 2 kilowatt, but I am unaware of this systems, power plants for 1 acre of land. So what is the procedure and all? Just I want to know, sir. If you are free, you can.
Advice is 1 acre is too small, so don't go to that open access model, because for 1 megawatt you need at least 4 acres.
Acha, 4 acres.
And if you start producing 1 megawatt, nobody will buy. You need to have at least 10 megawatts for large customers.
Okay.
Suppose even if you start and you have money for say 1 megawatt, say around 4 crore rupees, you invest and nobody buys energy, then you will be under loss.
Okay. So the client is asking whether he can export it to the government. It is feasible for that?
See, government selling to the government is very difficult, because they call for tenders. Then you should participate in the tender. Then they will ask you to supply at 3 rupees or 2 rupees 30 paise. So all this tendering process will be there.
Okay, sir. Okay.
It's not advisable for a small piece of land.
Okay. So at least 10 megawatt project is acceptable.
Yeah. For open access, you should have at least 10 megawatts.
Jazakallah. Thank you.
So can I ask you a question, please? Hello.
Yes. Go ahead.
Yeah, actually, I'm Dr. Amjad Kadri from Mumbai.
Okay.
No, it is like you said that for 1 megawatt you require 4 acres of land. So for 10 megawatt you'll be requiring what, 40 acres of land? Huh?
Yeah.
Is it that way, or is the conversion something different? That is it that 20-25 acre will do for 10 megawatt? I'm just for my knowledge.
See, nowadays the size of the panels is shrinking. So earlier we used to consume 5 acres of land per megawatt. Now it has come down to 3 or 3.5. But you need more space for the walkways, for vehicle movement, for maintenance, for the transformer yard. You need some land. So you can take it as 3 or 3.5 acres of land per megawatt.
Okay, because our panels basically are 1.1 meter by 2 by 2 meters. That is Tata's. Basically, I work with a person who's a parent distributor for Tata, so we have that sizes. And I've since I belong to Konkan region, I do get these kind of inquiries. What brother from Bihar has got. That is the reason I was asking.
Yeah, you can cross check with your consultant whether in 25 acres he can put 10 megawatts.
Okay. So, any idea where I can get more knowledge about this subject? Because I've just joined new. It is basically as my retirement work, you can say.
Okay.
So, I would like to have more knowledge about this field. So, where can I get more knowledge if need be?
See, the basic knowledge you can get from so many skill development institutes, but that is not what you are seeking now.
Right.
You want a higher level of this one. It is better
Absolutely.
to join hands with some consultants as a working partner or
Okay.
some investment partners, and then you can take things forward.
Okay. Thank you so much, sir. So, if need be, can I be in touch with you further if I need some guidance? Is it okay with you?
Yes, 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 yes. Please.
Thank you so much, sir. Thank you so much.
जी अस्सलाम वालेकुम।
वालेकुम सलाम।
मैं सऊदी अरब से बात कर रहा हूँ, उस्मान है मेरा नाम।
जी,
मैं
जी।
एक्चुअली आईटी बैकग्राउंड का हूँ।
जी।
मैं जैसे कि घर पे जो इंस्टॉलेशन कर देना है उसका बिजनेस शुरू करना चाह रहा हूँ, मतलब उसका एज ए क्लाइंट बोलिए मैं करना चाह रहा हूँ, हेल्प करना चाह रहा हूँ, मतलब इस तरह से बिजनेस में। तो
बिजनेस
कुछ
करना चाह
ऑप्शन
रहे
है
हैं
क्या?
सब्सिडी
जी,
वाला?
बिजनेस करना चाह रहा हूँ जी। और घर पे जो लगाते हैं सर पैनल वगैरह जो भी है वैसा यूज करना, वैसा इनबिल्ड करना चाह रहा हूँ घरों पे।
वो सब्सिडी वाला बिजनेस करना चाह रहे हैं?
जी जी
हाँ, देखिए, टू बी ऑनेस्ट विथ यू, जितना सब्सिडी का बिजनेस कर रहे हैं डीलर्स, आप उसको 10 आदमियों का लिस्ट लीजिए आप, और उसमें पूछिए कि भाई आर यू हैप्पी विद द बिजनेस मॉडल, तो आउट ऑफ 10 मे बी 7 to 8 people are, they are not happy, they are not making any good margin, good profits in the business,
ओके
because you have to deposit 2.5 lakhs to the ESCOM in each state. Suppose if you are from Telangana?
No, I am from, yes, Telangana, Hyderabad, sir.
Hyderabad, Telangana. So
Yeah.
you have to deposit 2.5 lakhs, then you have to give 5 years warranty, then you have to buy only DCR modules, and then
Okay.
installation cost is easily around 3 to 5 rupees per watt. So, but in the market, people are giving just 1 rupee, 2 rupees per installation per watt. So there, if your price is not competitive, then you will not get the order. So just be careful, do some due diligence, check with the market profitability.
Okay.
If it is giving you at least 20% gross margin and 8 to 10% net margin, you can
Okay.
start.
Okay, sir. Thank you so much. Jazakallah khair.
Thank you. Welcome.
नजीम भाई, एक और सवाल था अबरार हुसैन
जी, फरमाइए।
ये जो सोलर पैनल्स का जो इंस्टॉलेशन होता है,
जी,
I mean, can we utilize the land for cultivation, vegetation and stuff?
yeah, very much, very much. That is called as agri-solar power plants.
No, my question was, by increasing the height of the structure, are
Yes.
are we reducing the efficiency of the?
No.
No. Okay.
No. You
Right,
can do it. It's a good idea.
Right. Because you don't want the whole land to go waste, just having panels.
Correct.
And you can also make use of that. So
It's a wonderful idea.
Just thought of a possible idea to
Yeah,
use the
nowadays
land.
you are getting top-con bifacial solar modules, which they are semi-transparent.
Right.
So the solar sunlight, it is not blocked 100%. It will perforate to the plants.
Right.
Yeah.
So are those dual panels more efficient?
Yeah, they are more efficient. Yes.
Right. And also maybe more costlier than the single side.
No, cost, insignificant increase in the cost.
Okay. Right. Okay.
Nazeem Saab, can I again bother you, please?
Proposal for?
No. I wanted to know more about this because I am having a land of 1 acre in my native place. So this vegetation, so heighted should be the solar panel from the land so that I can cultivate vegetables over there.
Yeah, there are some consultants for agri solar.
Okay.
I will try to connect you to them.
Please. So that will
Okay,
help
you
me,
can talk to them. Yeah.
Yeah, because I'm having a bungalow also there, so that can take care of that power as well, and it will help me in agriculture as well. So I'll not be losing any land.
Yeah.
Thanks a lot. Thank you very much, sir.
Inshallah.
Once again, thanks for your time, Nazeem bhai. Shukriya.
Yeah, welcome. Thank you so much.
Thanks a lot, sir. Thanks a lot. Jazakallah khair.
Yeah,
जी
welcome.
जज़ाकल्लाह खैर।
Yeah. Just I want to improve my presentation, my skill development techniques. I need your feedback. Like, how do you rate my presentation out of 10 on the scale of 10?
नदीम साहब, एक क्वेश्चन है अमजद सिद्दीकी बोरो, आपकी कोई डिटेल ट्रेनिंग प्रोग्राम है क्या इससे रिलेटेड, सोलार से रिलेटेड?
Actually, I'm designing one course content that is still not completed. Once it is finished, I will share with you.
ओके, थैंक यू। तो
Don't give me 10 out of 10, otherwise I'll not improve. Mubin Sheikh is giving 10 on 10.
सर आपके प्रेजेंटेशन में आप फोटोज वगैरह भी और वीडियोस वगैरह बताया तो बेहतर रहता और अंडरस्टैंडिंग के लिए बहुत अच्छा रहता।
वो एक्चुअली क्या हो गया, मैं माजरत चाहता हूँ, एंड आई कुड मेक आउट दैट माय PPT was very boring and very simple without any videos, without any pictures. I had a very short notice for preparing this. Maybe inshallah next time I'll come back to you with more stuff on that, inshallah.
Hello, Assalamu alaikum, sir. Hello.
I had some very interesting videos also, but I'm not prepared to share now. From my EPC sites, practical live projects, I have captured some videos. Like, for example, what is arcing, how arcing happens, which we normally show to our students. So, but I'm not fully prepared to share the videos. Maybe inshallah next time I will share with you.
Hello.
Nazeem साहब, एक सजेशन था कि if you could show what is a bifacial photovoltaic cells कैसे रहते हैं और मोनो जो रहते हैं वो, अगर आप इसके अगर विजुअल्स बताते हैं तो ज्यादा मेरे ख्याल से हमारा ये जहन खुल जाता।
Yeah, I missed that actually. I wanted to briefly explain what is the difference between monocrystalline, polycrystalline, bifacial, monofacial, all those things. Yeah, I missed that. Yeah.
So please do remember us. जब आप ये दिखाने वाले रहेंगे तो please include us so we can join and learn that as well.
Inshallah. Okay.
Yeah. Okay. Thank you so much.
Thank you. Jazakallah.